In this problem, we'll look at mixing acid solutions. We're given that solution A is 25% acid, solution B is 40% acid, and we're asked how much is needed to make 60 liters of a solution that is 30% acid. Our first step will be to familiarize ourselves with the situation. The first thing we're going to do when we do that is to read the problem again and notice that A is a weaker solution, B is a stronger acid solution. We want to get 60 liters altogether, and it'll be of a 30% will be in between the 25% and 40% acid. You might even note that since 30% is closer to 25% than it is to 40%, we probably want a little bit more of solution A than solution B. That might be just a check we could look at the end. Now, when we familiarize ourselves with the situation, after reading carefully, we want to define variables. Since we're talking about solution A and solution B, I'm going to let A equal the amount of solution A, and this will be in liters, and B equal the amount of solution B. Choosing A and B here will help remember what they stand for. Now, when we do a mixture problem like this, it's a very good idea to use a table. In the table, we can make each column stand for the different kinds of solution we're looking at. We're looking at solution A, solution B, and the mixture. So we have these columns. Now, what about the rows of the table? Well, we'll be looking at the amount of the solution. We'll be looking at the percent that is acid. And the other thing that we'll be looking at is the amount of acid. Now, this is not the same as the percent of acid, but this is actually the amount of the solution that is acid. And we need all three of those pieces of information. Now, what I do is I fill in what I know. I know how much mixture I want total. I want 60 liters. I know the percent acid for all three. Solution A was 25% acid. Solution B was 40% acid. And the mixture we want to be 30% acid. Now, is there anything else I know? Well, I've defined two variables, A and B. I'll put those in. The amount of solution A was A. The amount of solution B was B. Now, how about this bottom row, the amount of acid? Well, I'm going to have to use A and B. Can't introduce any other variables here because I'm only going to have enough information to solve for two variables. But what I can do is I can think if I have A liters of a solution and 25% of its acid, then the amount of acid is 25% of A, or 0.25 A. The amount of acid in solution B will be 40% of B, which is 0.4 B. And the amount of acid in the mixture should be 30% of 60, or 0.3 times 60, which is 18, and that'll be 18 liters. Now, if you can fill in this table, the equations read directly from this table. The amount of acid the amount of the solution, A plus B, has to add to 60. The amount of the acid in A plus the amount of acid in B has to equal the amount of acid in the mixture. These two rows will give us the translation of our problem into mathematical language. So reading across the top row, thinking of the amount of solution, we would have A plus B equals 60. Reading across the third row and thinking of it as the amount of acid in the mixtures, in each separate solution and in the mixture, we have 0.25A plus 0.4B equals 18. Now, before we go ahead to the next step, solve, let's take a look at this second equation, and we're going to clear decimals in order to make it a little bit easier to solve. To clear the decimals, we see that we have hundredths here, tenths here, and no decimals here. If I multiply everything by 100, I will have no decimal places left. So multiplying this by 100, I'm going to copy my first equation. I'm not going to change that. And multiplying everything in my second equation by 100, I have 25a plus 40b equals 1800. And now I'm ready to go to my next step, and that is to solve the system of equations. And I want to solve this for the ordered pair AB. I'm going to use the elimination method, and I'm going to multiply equation 1 by negative 25 and then add to eliminate the a terms. So multiplying the top equation by negative 25, I have negative 25a minus 25b equals negative 25 times 60, which is negative 1500. I just copy my second equation, 25a plus 40b equals 1800, and then I add. This adds to 0, this adds to 15b, and this adds to 300. Dividing by 15, I have b equals 20. Now remember, I want a and b. Substituting 20 for b in my first equation, I would have a plus b equals 60, a plus 20 equals 60. Subtracting 20 from both sides, I have a equals 40. So I have a possible solution of a is 40 and b is 20. Now we will check those possible solutions as step 4. Check. We have that a is 40 and b is 20. And we can see that we would get 60 liters of the solution. Will it be the right amount of acid? Well, as you recall, 25% of solution A was acid. So 25% of 40 plus 40% of 20 will give us the amount of acid that's in the solution. If we add this together, 25% of 40 is a fourth of 40, or 10. 40% of 20 is 8, and that would give us 18 liters. And that is what we calculated we needed as for the amount of acid in the solution. So our answers check. And we can state, as our last step, that 40 liters of solution A and 20 liters of solution B should be used.